Hello, this is the generally approachable Sudoku for the 12th of March 2024. It is Collisions by Philip Newman, and it is an arrow Sudoku, so let's take a look at the rules. Normal Sudokus apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along arrows must sum to the circled total, so those digits, for example, sum to whatever digit that is. If this digit was like a 5, for example, then you could have a 1, 4 in here because they sum to 5. So those are all the rules, and really that's just it. So with that, let's just begin solving. Okay, so I realize that every arrow is filled except for the 4 here. Those are not filled, but it should be fine. Let's start with the ones that are filled first. We have the ones in the corner, and actually they are particularly interesting as compared to the rest of the arrows, because each of their arrows is exactly 3 digits long, which is a lot more cool than, well, they're cooler, but they're also more useful than arrows that are 2 digits long, because the minimum digits you can have on such an arrow is actually 1, 2, and 3, because they all occupy the same column or row. Therefore, the minimum you can have on them is 1, 2, and 3, which sum to 6. Those digits, for example, the one that attached to 6, are exactly 1, 2, and 3 for that reason. Those digits also have a specific combination because they sum to 7. They can only be 1, 2, and 4. And I guess I've already said this multiple times, but the way to figure out how to get 7 in 3 digits is to consider the lowest 1, 2, and 3. They sum to 6, but you need one more. Therefore, you need to increase one of these digits by 1. However, because they all occupy the same column, they cannot repeat. Therefore, you cannot increase 1 or 2 by 1 because they would cause repeated digits. Therefore, you can only increase 3, which gives you 4, and 1, 2, and 4 are the only digits you can place to make 7, which they do. Now, the 8 also has some tricks. The 8, in fact, must include a 1 somewhere, and the reason why is because without that 1, your minimum sum of digits would be 2 plus 3 plus 4, which is 9, which is already too large. So the 8 must have a 1 in it. And 9 has basically no restrictions, other than the fact that it cannot contain a 7 or an 8. Or a 9, obviously. But okay, we can probably continue on with these triples that we've formed. Those digits, for example, have to sum to, well, they, at minimum, because they can't be 1, 2, or 3 anymore, they have to be at minimum 4 and 5, which add up to 9, which is perfect because this is also the maximum they can be. They can't be any higher than 9. So they have to be 4, 5, which makes 9. That digit now is the last digit in its row, which must be an 8, which means that digit is 1 to form a sum of 9. This 1 removes 1 from both of those cells, pushing a 1 down in that cell, which could do something. 1 is no longer in that cell. I mean, those digits are at least 3, 6. Ooh. Because they can't contain a 5, the minimum you can put on the arrow is a 3, now that 1, 2, and 4 are missing. And after that, because 4 and 5 are also not available, the next smallest you can put is a 6. And so the minimum here is a 3, 6, which sums to 9, but that's also the maximum it can be because this cannot be greater than 9. So it must be 3, 6 adding to 9. Our last digit here is therefore a 5 to finish the column. Cool. No, those digits actually sum to 5, which is useful because 1 is not allowed. And to make 5, there are only 2 possible methods. You can either do 1 plus 4 or 2 plus 3. 1 plus 4 doesn't work because 1 is already in the column, so it must be made of 2 and 3. The 2, 4 pair here removes 2 from that cell, so that's 3. This cell is therefore a 2. We can also place 9 in this box because of this 9 over here. 9 must be there. That forms a triple consisting of, I believe, 4, 7, and 8, sorry. Actually, we can remove a lot of stuff from here actually because that digit cannot be 8 by the row. It also can't be 4 because a 4 would place a 5 to make a 9. But 5 is already in the row, so it must be 7, which has a 2 as a partner to sum to 9, and 7 is removed from both of those cells. We can have more triples here actually. That triple is 4, 6, and 7. Nice. Whoa, 4. And those digits are therefore 1, 2, and 3 to finish the box. Those digits are actually just 5 and 6 to finish the box as well. Right. Now we can remove 4 from that cell because 4 requires a 5 in this position, which doesn't work. We can also remove 1 from this cell because 1 requires an 8 here, which also doesn't work. we can do more removals by saying this can't be 7 or 6 actually. Yeah, in fact that is really interesting. It can't be 6 or 7 because 6 here, well, the remaining 2 digits have to sum to at least 3 because you have to use 1 and 2 at minimum. Therefore this digit cannot be 6 or higher because that will give you a sum of 9 or higher. So this must just be 4. Those digits therefore sum to 4 to make 8 and therefore must be made of 1 and 3. That's the only way to make 4 and 2 digits. This digit now cannot be 3 because it also requires another 3 here to make 6. But it also can't be 1 because a 1 here requires 5 here to make 6, but 5 is already in the row. So it must be a 2 with a 4 as a partner. This 2 resolves this 3 up here, which pushes a 1 down there. That resolves a lot of stuff. 3 must be with 6 to make 9, which puts a 7 there. Cool. Now those digits... Well, another trick in arrow Sudoku is to consider the largest digit in this set. Right, the remaining digits here, well, they consist of 2, 5, 6, and 7. And we know a 7 must be here. And the reason why is because this digit is always greater than all of those digits. Because those digits add together to make 7 and must therefore be smaller than 7. Otherwise one of them will be negative, which doesn't work. So the largest number 7 has to be in the middle, or in the circle. And because we have 2, 5, and 6 as our remaining digits, those digits have to sum to 7, and the only way to make that work is 2 and 5. You can also say because of this 6 that 6 is removed from those cells. So now 6 is over there. That digit is a 1 to finish your 7. And this one removes a 1 from that cell. Now how does that help us? That forms a triple here, I guess. That has to be 3, 8, and 9. And we know 9 is not in both of those cells because the 9 here removes 9 from those cells. 9 goes in here. 8 also can't be here because once we also really said before that those digits have to sum to at most, or at least a 2. So that digit cannot be as high as 8. So that's 3, that's 8. Now those digits sum to 6, but we don't know how, I think. That's fine though because that forms more triples. Those have to be 4, 5, and 2. And those digits have to be 1, 7, and 8. Now 7 is removed from that cell. Actually this 1, 8 here does something very special because both of those digits sum to 9. If it was a 1 it requires an 8 here, if it's an 8 it requires a 1 here, giving you a 1, 8 pair. Now this digit pairs with that digit to form 9 as well. We can actually like put in the options as we go along. 2 must be with 7, 4 and 5 must be with each other. This one also sees this because they must sum to 8. 2 must be with 6, which isn't possible because 6 is already in the column. 4 is also not possible because 4 must be with itself, which doesn't work. So it must be a 5 with a 3. That resolves this 3, 6 pair. Those digits are now no longer 5. Because this can't be 5, that cannot be 4. Now those digits on the 6, and because of the 2, 4 here, that digit is also 2 of 4, because that is the pair we need to make 6. Right. Now where does 1 go in this column? It's a bit hard to spot, but 1 can't be in those cells. 1 also can't be in here, because no 2 digits can sum to 1. They will have to both be like 1 or less, which doesn't work. So 1 can only be here, which works, and those digits form a pair, which have to be 4 and 6. Now, does that resolve? I don't believe so. Nope. Okay. Well, I suppose the question is now what? I mean, 1, 2, 3, and 4 are here. This could be a 5. Could it be any higher than 5? I mean, those are just from a triple, so I guess we should analyze that instead. This is 5, 7, and 8. Right, and now because of this 1, we do know that this is exactly 1 more than that. Because this plus 1 gives you this. So the only way to make that work is 8 with 7. 5 goes up here, which resolves this 5, 6 pair. Hopefully it does more stuff. This 3 puts a 2 in there. And now we probably have a ton of triples to work with. Maybe not though. Alright, how about those digits? Those digits have to be 1 and 7 because they can't be 3, 5 and they can't be 2, 6. So they have to be 1 and 7. This one resolves that. This one also places a 3 up here. and also gives us a pair here. Sorry, this has to be 4 and 9, and clearly because this forms 7 with another digit, this can't be as high as a 9. So that's a 4, which must be with 3. This pushes a 9 down there. This 4 puts a 6 here. And this 4 also resolves this 2-4 pair, which gives us a lot of stuff. Does it do anything? I think that is just a 4, and those digits are therefore 5 and 9. Yes, this 9 resolves that. So 5 here, 9 here, 5 puts a 7 there. 7 is not in that cell, therefore this forms a 1-8 pair, which forces a 7 down here. Anything else? This forms a 1-4-8 triple, and because of this 4, this can't be a 4 either. Therefore this 1-8 pair puts a 4 here and an 8 up there. Those digits form a triple. They have to be 3, 5, and 6, sorry. And because of the 3s, those digits can't be 3. 3 goes in the middle. 5, 6 I don't think is resolved. No. Okay. Well, this 4 resolves this 2-4 pair, giving us a single digit here to place. That has to be an 8. That resolves a bunch of stuff. 1, 8, 1, 8. Does that help? Not sure. Alright, those are forms of triple. What are they? 2, 6, and 9. Nice. The 9s probably resolve everything. Yep, 9 goes there. 6 resolves this 2-6 pair here, which resolves this 2-5 pair, and now we are going on a round. This 5 resolves this 4-5 pair up top, and this 5 resolves this 5-6 pair over here, which solves the puzzle in 11 minutes and 6 seconds. Nice. Well, I hope you enjoyed this puzzle. It teaches a lot of arrow tricks, so I find that very cool. So yeah, hope you enjoyed this video. I'll see you guys next time. Bye bye.